you must write an algorithm with O of log n runtime complexity. Okay, so for example, like this is an ascending order. Your target is 9. You need to return the index 0, 1, 2, 3, 4. 9 is the fourth index, so you return if it exists. If it doesn't exist, like 2, you return -1. Okay, so for Go, like this is like quite a very simple problem. Most languages does have the built-in packages, so we'll probably look into all of it and then try to all the possible solution for this problem. So for this case, let's start with a basic one where you could just simply use the library which Go comes with. It's in the sort package, and you do have a search int here, which search int that search allows you to search particular value in the target. Now you need to make, the only concern here is the result. The result is actually the position where it needs to be inserted, and it could be more than the length, yeah, if it's not present. So which means it's if it's there, so you really have to check if the nums for that I is actually equal to the target. Make sure that it's the same, else it will be, if it's not, then it's returning the position where you want to insert that value. And you need to make sure that I is less than the length of num, because it's possible that the return value is more than the number index, the length of the num. So you just return I here, and if you cannot find it, you return -1. Okay, submit. Yeah, there you go. It's very straightforward, nothing really fancy here. But what we want to do is take a look into what its search is doing inside. Yeah. So, assuming that we have a number of 1, 2, 3, 4, 5, 6, 7. Yeah, and the good thing about this is all the integers are unique, so you don't really have to worry if it's the same. Well, it doesn't really matter if it's the same, but you need to put some less than equal check later on. So this made the problem much easier because all the integers and numbers are unique. So yeah, for example, the input is 1, 2, 3, 4, 5, 6, 7, and you're looking for target is let's say 3. The way binary search works is you go to the middle because it's already sorted, right? Go to the middle, like 4. Is 3 less than 4? Yes, it's less than 4. So you go search for the left, which is you try to search for 1, 2, 3, right? And that's your range now. How do you compute the middle? You compute the middle is equal to the length minus 1 minus low, high and low. High minus low divided by 2. So basically this is how you compute. Like high plus low divided by 2. Or high is like 0, 1, 2, 3, 4, 5, 6. Because you're starting with index 0, so this is your 6. 6 minus 0 is 6 plus 0 divided by 2 is 3. 0, 1, 2, 3. So in this case, middle equals to 4. Yeah. And 3 is less than the value 4. So what's happening there is you want to move your high until this range, right? So 1, 2, 3, 4, which is your mid now, is your high now is 3. 3 minus 0 is 3 plus 0 is 3 divided by 2 is 1, which is 2. So this is now your middle, 2 and 1. It's actually 2 is greater than 3, right? So if it's 3 is greater than 2, you now go to 2 and 3 on the other side. Right? Yeah, so 2 to 4. So you now search for 2 to 3. And eventually you get 3, then return 3. So basically you go left, then you go right. This is how you actually try to search for a particular value in ascending order. You basically go to the left, or either you go to the right. And it's the runtime is log n, because you keep on dividing your list into 2. So either you go to the left or you go to the right, which just makes the list so smaller and smaller. So let's try to implement that in Go using that approach. So you know that the middle is like high plus low, whatever that's, right? and we need a high, which is the len of nums, and then you have the low, which is 0. So this is basic. So you keep on looping until basically the low is less than equal to high. Just keep on doing that, and you compute the mid. There's another implementation of the mid, and that is high minus low. You add low here. The reason you want to do this, you don't want to go for the overflow, because high plus low can result in an overflow, right? Because if you're using an integer and then 2 integer plus integer, you gotta have more than the maximum integer. So you do want to use the minus instead. And then if you do the minus, you need to add the base offset for that. So how you do it, and then if nums middle is equal to the target, then you found the result. So you just return, right? Else if your target is greater than nums, you know it's on the right side. If you want to go to the right side, what you need to do is move the low takes the mid plus 1. Else it's on the left, so that's high, you move high, mid minus 1. Yeah, pretty straightforward. And then if you cannot find it, you just return -1 here. So let's try it out. Okay, should be M. Actually, you can name it as mid. Rather name it as mid, so it's more readable. So, mid. So mid. Right. So I think what you need to do is -1, so you don't go overboard, right? When you compute it. It will be within the range of that mid. That's it, and you submit. So there you go. This is the iterative solution, but we could do a recursive approach on this. And let's try to do the recursive approach. Just call it search 2 with low and high here. Comment this out. So it's basically just the same, except that the loop will be done by this recursion. So a while ago, your exit condition is if it's always less than, but we're gonna put the exit condition as this. If this is greater than something like that, then we return -1. Basically, you cannot find it. Okay. And then we compute the middle. If you found the target, that's it. Instead of this like this, you could call the search to and then pass the nums target. Okay, this is where you need to make the logic correct. So basically your low now becomes mid plus 1, and we kept the high, right? And then same thing, same goes here. The high becomes mid minus 1, but you keep the low. You keep the low. That's how you basically do this. And then you don't need this, and then you don't need this, because yeah, that's it. Actually, a better approach would be something like this. If this one is like this, then if this one is like this, greater than, so you don't have to put this part here, so it's always assumed at the last part that it's equal. Yeah, return mid. You know that it's equal, so you just remove this one. If doesn't target search 2, okay, try it out. Unexpected return, you need to put a bracket here. For Go, you always have to put a bracket at the end of function statement. Okay, so in this case we just call this one search to pass nums target Low is 0, high is yeah, len minus 1. So there you go, submit it. Yeah, there you have it. So this is the recursive solution. What is fine, but usually I prefer to use the iterative one because it's very simple. You don't really need to like use the recursive function. So that's it. That's how you do a binary search in Go. This is a very fundamental thing. In actually, binary search only works if the values are in ascending or sorted order. If it's ascending, you'd have to switch your condition here. But it needs to be a sorted way. It cannot work if it's not sorted. So yeah, that's it. If you like the video, please feel free to hit like and subscribe. So yeah, thank you guys for watching, and yeah, please don't forget to hit like and subscribe. Yeah, see you again next episode. Bye.